So this question here is today another important question or a very crucial question that is asked in every interview for performance testing or engineering. So the question is, what is thread dump and why thread dumps are important in performance engineering? So first I will tell you what is a thread dump. So a thread dump, also known as a stack trace or thread snapshot, is a snapshot of the current execution status of all threads in a running Java application. And this thread dump provides valuable information about what each thread is doing at a particular moment, including the method and line of code it's executing. So here is why thread dumps are important in performance engineering. So the first point is diagnosing the performance issues. So thread dumps are a powerful diagnostic tool for identifying performance bottlenecks and any excessive CPU usage or for any application freezes. So it diagnoses all of these, especially the performance bottlenecks, to identify the performance bottlenecks and to diagnose the excessive CPU usage and to check for any application freezes. So by analyzing the thread dumps, performance engineers can pinpoint which threads are consuming CPU resources and identify potential issues. And the second point is detecting the deadlocks. So thread dumps can reveal the presence of deadlocks which occur when two or more threads are stuck in a state where they are waiting for resources held up by each other. So identifying deadlocks is crucial for maintaining application stability and responsiveness. And the third reason is to analyze thread behavior. So the thread dumps allow performance engineers to analyze the behavior of threads, such as whether they are stuck in an infinite loop, blocked, or waiting for input-output operations. And this information is essential for troubleshooting and optimizing thread performance. The last reason is the profiling and optimization. So thread dumps can be used in conjunction with profiling tools to gain a comprehensive view of application performance. So performance engineers can identify bottlenecks, long-running threads, and areas of code that require optimization. So these are what we call as thread dump, and why are we more concerned about the thread dump, like why do we really need to look into the thread dumps. And next comes the deadlock. So what is a deadlock? So a deadlock is a specific type of concurrency issue that occurs in a multi-threaded application when two or more threads are unable to proceed because they are each waiting for a resource that the other holds. So in essence, they are locked in a circular dependency and neither can make process. So I'm just giving you a simple example of how a typical deadlock occurs. So at the thread A, so we have two threads, one is thread A and the other one is thread B. So the thread A acquires a lock on resource X and the thread B, the second thread, acquires a lock on resource Y. So there are two threads and two resources. So now the thread A attempts to acquire a lock on resource Y, but it's already held by thread B. So the thread A becomes blocked waiting for the resource Y to be released. So now the thread B attempts to acquire a lock on resource X, which is held by thread A. So thread B becomes blocked waiting for resource X to be released. Now both the threads are stuck waiting for resources held by the other and the application reaches a standstill. So in performance engineering, deadlocks are a significant concern because they can severely impact application responsiveness and reliability. So by detecting and resolving deadlocks often involves analyzing thread dumps. So as mentioned earlier, thread dumps are valuable for identifying deadlocks. So performance engineers can examine thread states and dependencies to pinpoint which threads are involved in the deadlock. And the next thing is the resource locking strategies, where we have to review and optimize the way resources are locked and released. So we have to ensure a consistent locking order that can help prevent deadlocks. And the third way to detect and resolve deadlock involves deadlock detection tools. So some performance monitoring and profiling tools include features for automatically detecting and reporting deadlocks, and these tools can be valuable in identifying and resolving deadlocks in real time. And the final one is the code review and testing. So we have to carefully review code for potential deadlock scenarios during development and conduct thorough testing, including stress and concurrency testing, to identify and address deadlock issues before they reach production. So, in summary, the threat dumps and the understanding of deadlocks are critical tools and concepts in performance engineering. Threat dumps help diagnose performance issues, including deadlocks, and deadlocks must be carefully managed and prevented to maintain the reliability and responsiveness of multi threaded applications. So, with that, I come to an end.